Hi everyone. My name is Martin, and today I'm going to be talking about how to write more performant SwiftUI code. First, some short info about me. I'm leading the iOS team at Stream, where we build open source SDKs for chat, activity feeds, and videos that are used by some very popular apps like Strava, Patreon, Midjourney, and so on. In my spare time, I'm also trying to build some indie apps. Currently, my focus is around kids, diapers, and learning first words and all that stuff. I sometimes also blog, and you can find me on Twitter. First, let's see what are the iOS performance metrics that are useful for determining whether an app is slow or not. Let's do an analogy. Imagine like I'm doing a presentation. That's probably not that hard to do. And I have separated the presentation in slides. And each slide has certain amount of time that I dedicated to do the presentation. However, if I get like too much talkative during a slide, the slide would be delayed, and I would either have to, cut something from the next slide, or even worse, I will steal something from your break. So in both cases, you as consumers, you will have like a bad experience, and this is basically what also happens with iOS. So you have like frames, and in each frame, you have certain amount of time to perform some work. And if you don't do that work on time, then there will be some laggy experience. And basically this delay, when a frame appears later than usual, it's called animation hitch. And the difference between when the frame appeared compared to when it was supposed to appear is called hitch time. And then if you compare like the number of hitches over a certain period of time, then you have something called hitch ratio. And these are kind of like the metrics that nowadays Apple recommends in order to measure the performance of an app. But we also have this like well-known frames per second, which is kind of like not really good enough to measure because different devices have different frame rates, and if you say 60, it might be good for some device and bad for some other device. So it's basically, sometimes it can be useful to explain some concepts, but in general it's better to use the other three. And now let's see what can cause these performance issues and what can cause hitches in our apps. So there are many things. Nikita already shared some of them. I've tried to summarize them like in at least 5. There are also more, but in general, the more common ones are misusing the SwiftUI components, then causing frequent redraws, then having things like off-screen rendering, heavy work on the main thread, and for example, using some large files in your apps and things like this can cause performance issues. There are many others like, I don't know, database access on the main thread and so on, but we will not cover those. So first, let's start with using the SwiftUI components. There is one interesting one which is called AnyView, and AnyView is basically a type erased view. So basically, it's not known. And to explain this, let's see this beautiful dog. And you can all see that this is a dog, right? And it's also on the sun, so let's put it some glasses. And now you know that the dog has glasses. So you know that the difference between this picture and the previous one is that now the dog has glasses. So next, let's see this sloth, which is a very lazy animal and very slow. And because it's slow, it sometimes hides in the forest, like it's camouflaged. So it's harder to spot. And if we do the same thing to it, like put some glasses, you will see, you probably, if you have bad vision like most developers, you probably won't even notice this. And you will just assume that I put glasses here. And basically, this is like an analogy for the any view. So SwiftUI doesn't know what this view is. And it basically just says, okay, I will redraw this thing because I don't know its type. And SwiftUI relies on the types of the views in order to determine the identity of the views. And it uses the identity in order to determine changes on it. So that's like the theory behind the any view. And why would you use it? Well, it's very handy in some cases. So, for example, you can build like, let's say you build like a newsfeed, and you want to build a section for liking, comments, and stuff like that. And usually you will have the same container that will have this logic, while the content inside would be different. So you would have links, you will have images, videos, and whatever is popular nowadays to be shown in a newsfeed. And if you use any view, it's very easy just to put everything there. However, if you use generics, you specify the concrete type, and the implementation can get a bit longer. So if you want to allow like putting several things, several views, you will need to be generic over several views, so that would increase the complexity. And there are ways how to solve this. So you can like create a protocol, define what are the injectable types, like we have here on the right. So this is like a very simple implementation from our SwiftUI SDK, how we allow to customize views to inject basically something from the outside. And it's a bit more boilerplate code. And now the question is it worth it? Is the theory that any view really causes performance issues correct or not? So in order to verify this, I did some measurements. So basically I changed the implementation of our SwiftUI SDK to use any view and compare it with what we have as default. And I measured like on an iPhone 11 and did things like, you know, scrolling, sending a lot of messages to see what happens, and measured this with instruments. And the results are very interesting. So with the generics one, as you can see, there are some small hitches, but if it's in the green area, then it's acceptable latency and users won't notice any glitch. While on the any view implementation, you can see this a bit larger orange rectangles, which means the hitches took longer, and these are like something that you should consider looking into your app. And then I also ran the hangs profile, and there were hangs, and the experience was like really noticeably glitchy. And when I quantified this with frames per second, because it's easier to compute the difference in performance, basically if you use any view, the performance degrades around 10% if you just browse through the data. If you force updates, like let's say you have some kind of message and people react on it, put a lot of replies, quotes, and so on, this message continuously updates and triggers a lot of updates as well. So this can even degrade the performance up to 17% and basically makes the behavior really like not good enough. And now the question is why this happens. So there are two things that we should generally avoid when we work with lists and views inside, like for each or lazy vstacks and so on. And those are these two. So the first one is if you have like a for each and you do if condition, that's very expensive and it can be reflected if you have a lot of views. And the reasoning for this is that SwiftUI, when it evaluates view and when it tries to draw it, needs to know the identifiers of all of its items. And if it has an if condition, it needs to visit every item to see whether that condition is satisfied, which means that it needs to do some extra work, and this basically causes some performance penalties. So ideally, you filter the data before, and you just give it something that's just presents some view on the certain slot without doing if conditions inside for each. And that's one thing. And then the other one is if you, what I've mentioned, if you use any view, SwiftUI doesn't know the identity of a view, and it just assumes it's a different view each time. So that's basically just the same as you would slap like an ID modifier with UID on a view, and it would be redrawn every time. So that's why ideally you should avoid it if you work with a larger lists of data. So if you have a menu, for example, with 5 items, you would probably not notice any difference. So next topic is, while we are still at view containers, Nikita already mentioned this about lazy vstacks. So he had a bit worse experience about this. In general, lazy means that something is created on demand. And of course, if you have a large list with tens of thousands of elements, or maybe that's too much, but maybe hundreds of elements, if you make it non-lazy, then of course everything would need to be rendered up front, and that would be very slow. And in those cases, it's best to use a lazy counterpart. While, for example, for the specific items in a row, if you go like into the other extreme of having everything lazy, then you will have different performance issues because everything would need to be created on demand. Then geometry reader, also something Nikita talked about, and he said that it's expensive to have it like as put in the background. So if you use multiple of them, that causes performance issues because geometry reader in general is a very expensive component to create. It's kind of like useful in sometimes because it's our gateway to the UI kit world where we could have frames and we can do some calculations. But in general, try to avoid it. So try to use spacers or frame modifiers when you want to do some frame calculations, or the new layout protocol is very powerful. So basically, in some cases, the geometry reader is still useful, but try to use only one. Try to organize the code in a way that you only have one geometry reader and not like put it in every item as a background, which people usually do that a lot. And if you run this like with thousands of elements, you will definitely have performance issues. Then another pretty common thing, so SwiftUI evaluates the bodies of the views very frequently, but by doing mistakes in our code, we can force it to redraw it even more. And that, of course, causes more performance issues. So this is a code that I actually written, and it's very slow. So it's kind of like on the left, there is some kind of like a view model, and you have a list of images and a method that returns an image. So if you have it cached, it returns it immediately, and if not, it tries to load it while returning a placeholder immediately. And when the image comes back from the backend, the published variable is changed. And now on the right side, you can see that we pass the whole function to every list item, which means it implicitly depends on all the images. So what this means is that whenever a new image comes, all the items would be redrawn. So the first time that the list is shown, when all the images are being downloaded, it would be very slow. So the takeaway here is the code structure really matters in SwiftUI. So try to make the views depend only on the state they need. So when that state changes, you only redraw the view that really needs to redraw. Otherwise, you will have frequent redraws, and that will cause performance issues as well. Then on this topic also, if you do things like unnecessary, it can also cause performance issues. So one example is if you do some kind of like a custom gesture, and when you do custom gestures, the methods like onChanged are called many times per second. And when this happens, if you try to modify the state like on every change, it can also change the view while you are dragging. So basically, you will have like a glitch. So ideally, either you check whether it's really changed, or maybe you put some threshold, like an optimization, to know whether it's a small like movement of the finger. So you try to be like more aware of these unnecessary data updates, because while you drag, you need to have like a consistent state. So in this case, it's an example of swiping a message and the point where it becomes swiped or not. Then another one which is pretty basic is doing heavy work on the main thread, and this is kind of like applicable also for UIKit, for Android, and everywhere that has this concept of a UI thread, which needs to be available for the user interaction. And if you have it busy for your own stuff, then your app won't be responsive, and this would cause like a bad user experience. And there are many examples like how you can do this wrong, and this is also a real-world example where with computed variables you can easily do these mistakes, because like you just see the view body and then you don't see like what's everything inside. And for example, let's say we have here at the bottom has attachment boolean that just is used, let's say, in a SwiftUI view code to show an icon or not. And if you just see the view, you won't notice this, but if you just dig deeper, you will see that this one depends on another computed variable, which also always loads the attachment, always decodes it, and then returns it, and then we just check whether this is nil or not. And of course, if we do this for every row, this would be very slow, and after 10 items, it would be very easily noticeable. So basically, computed variables are one way where you can really make performance issues in a SwiftUI app. Then another thing that can cause performance issues is off-screen rendering. And what this means is that the GPU at some point might decide to draw something on like on a different place, on a temporary place, and then draw something else and then merge those together. And an example of this is like applying shadows to a view. So if you use like dynamic shadows, it will just create first the shadow, put it somewhere else, and then take, let's say it's a button, then it would apply the shadow to the button, and this process of putting it into a temporary place and then bringing it back, it's called off-screen rendering, and this can be expensive. And luckily, Xcode allows us to track these issues. So if you are like in a debug mode and open here the debug view hierarchy, like on the image, and then go into the editor and select show layers and show optimization opportunities, you will get this list on the left in the picture with suggestions like what is expensive to render in your app, and basically go from there and try to fix it. So for example, here you can see it says that dynamic shadows are expensive to render. If possible, try using the shadow path. And with these kinds of things, like small improvements can make a big difference in terms of performance, especially if this is repeatable work. So most of the stuff that I'm mentioning is noticeable in bigger lists of data. And while we are talking about these big lists of data, if you are building like lists, images are also very important. How big they are, especially if you first render them as thumbnails. So for example, if you have an image that's 20 megabytes big and you want to put it in a 40 points like size view, of course it would be very slow. So ideally in these cases you would have some support from your backend, from a CDN, and you will just provide your view size and it would give you a smaller thumbnail. But if not, you can also do it locally. So there, for example, you can resize images locally on a background thread, and when they are resized, just show them on the screen. So that would also help performance. So how do we detect these issues? I usually use the Instruments app. It's very useful and it provides a lot of details about what happens. And I find the time profiler very useful. Then for SwiftUI, the SwiftUI profile, because it gives you like how many times a certain view redraws. Then what else? There is also the animation hitches profile, which gives you like the hitches. We've seen that one before. And then also we have for hangs and like for any kinds of stuff. We have for leaks. It's quite useful app if you haven't used it so far. It can be a bit overwhelming at first, but once you learn how it works, it's very useful to master. Then when we do the performance updates, we are happy with our performance. Over time, we would probably, again, make it slower by adding new features over time. And the best way to prevent this is to do performance testing. And the idea here is like basically to become faster by never getting slower. And we do this by running tests, performance tests on, for example, each PR before we merge to our main or develop branch. And luckily nowadays, Xcode has some useful exit test in general has some useful tools like this signpost metric called scroll deceleration metric, where you can do like swiping up, swiping down tests, and it will measure like how fast the scrolling is. And it gives some data. So this is from our Stream Chat SDK. So we run this on every PR. And you can see things like duration, the hitch time ratio, the number of hitches, how many frames per second. And then we have our base branch, and we compare this to the base branch, and we show like what's the performance difference, so whether it's slower or faster, and we have some kind of status. And if it's green, we are good to go to merge it, at least from performance perspective. And if not, basically we need to do some changes before we can merge it. And luckily, as I've mentioned, our open source SDKs are open source, and this is in our fast file, and you can just grab it and use it in your apps, because the world would be better place if there are faster apps. And as a summary, be aware of the SwiftUI components and their redrawing mechanism. Be careful when you use the main thread. Instruments are very useful, and do performance testing to avoid regressions. So with that, I want to thank you for your attention, and special thanks to our organizers who did really tremendous job in organizing this conference. For me, it's really the best feeling to be able to speak in front of the Macedonian audience. Thank you.